Hello everyone, let's draw the Lewis structure of SO2, that is sulfur dioxide. To draw the Lewis structure of a molecule, we need to know the total number of valence electrons. Atomic number of sulfur is 16 and therefore the electronic configuration is neon, that has 10 electrons, and then 3s2, 3p4. This means that we have 6 valence electrons in sulfur, we have only one sulfur atom, therefore 6 here. Atomic number of oxygen is 8, therefore the electronic configuration is helium, that has 2 electrons, and then 2s2, 2p4. In oxygen 2 we have 6 valence electrons, both sulfur and oxygen belong to the same group. However, we have 2 oxygen atoms in SO2, therefore 6 times 2, 12. So in total we have 18 valence electrons in SO2. Sulfur is less electronegative compared to oxygen, therefore let's put the sulfur atom in the center and oxygen atoms in the end. Let's make one chemical bond by putting 2 electrons between sulfur and oxygen. Let's put the remaining electrons as lone pairs. This oxygen atom now has 8 electrons around it. Let's put 3 lone pairs on this oxygen too. Now this one also has 8 electrons around it. So 8 plus 8, 16. We still have 2 more valence electrons because we have 18 valence electrons here. Therefore, let's put one lone pair on sulfur. Now if we do that, though the oxygen atom satisfies the octet configuration, the sulfur atom doesn't satisfy the octet configuration. We have only 6 electrons around sulfur. Therefore, let's bring one lone pair to the bond pair. Therefore, let's write it this way. Sulfur and then 2 bonds and then oxygen and then 2 lone pairs, and then on this side single bond between sulfur and oxygen and then 3 lone pairs and then 1 lone pair on sulfur. Now all atoms do satisfy the octet configuration. You might think that this is the best Lewis structure for SO2, however it is not. If you write the Lewis structure this way, then we need to enter a formal charge of +1 for sulfur and -1 for this oxygen atom that has 3 lone pairs. The preferred Lewis structures are those where all the formal charges are 0. Therefore, this is not the best Lewis structure. Let us briefly discuss how we calculated the formal charges here. Formal charge is equal to total number of valence electrons in the atom minus total number of non-bonded electrons in the molecule minus total number of bonded electrons in the molecule divided by 2. Therefore, for sulfur it will be 6 minus we have 1 lone pair, therefore 2 here, minus we have 3 bonds, therefore 6 by 2. So this means that this is 4 minus 3 and that is equal to +1. That's how we entered a formal charge of +1 here. And for this oxygen atom, it would be 6 minus, we have 3 lone pairs, therefore 6, minus, we have only 1 bond, therefore 2 by 2 and that is equal to -1. That's how we got -1 here. And for the other oxygen atom, if you calculate the formal charge here, it will be 6 minus 4 minus, we have 2 bonds, therefore 4 by 2. This means that 2 minus 2 and that is equal to 0. Now, if you bring one lone pair to the bond pair, then we can get a formal charge as 0 for all the atoms. Therefore, the best Lewis structure for SO2 is sulfur, 2 bonds, oxygen and then 2 bonds, oxygen, 2 lone pairs on each oxygen and then 1 lone pair on sulfur. You might be thinking, if we write like this, are we not violating the octet configuration? That's what you might be thinking, because now we have 10 electrons around sulfur. However, sulfur is in period 3 and therefore it can accommodate more than 8 electrons. Therefore, writing a Lewis structure like this is completely fine for SO2. Now let us calculate the formal charge for both sulfur as well as oxygen. If we calculate the formal charge now for sulfur, then it is 6 valence electrons in sulfur minus we have 1 lone pair, therefore 2, minus we have 4 bonds now, therefore 8 by 2. So, this means that 4 minus 4 and that is equal to 0. So, now we are getting a formal charge as 0. So, if you calculate the formal charge for oxygen, you will get 0 because we have 6 valence electrons in oxygen 2 minus we have 2 lone pairs each, therefore 4 here, minus we have 2 bonds, therefore 4 by 2. So, this means 2 minus 2 and that is equal to 0. A Lewis structure that has 0 formal charges is much more preferred than the Lewis structure that has charges and atoms, and therefore, this is the preferred Lewis structure for SO2